Today we're going to talk about metallurgy. Now I know, it sounds kind of technical, but trust me, this is the hidden science that literally builds our entire world. It's this incredible process that takes a simple rock and turns it into, well, everything.
Seriously, just for a second, look around the room you're in. Your phone, your keys, the zipper on your jacket, maybe the chair you're sitting on. Metal is just everywhere. You can't escape it. But here's the crazy part. That's right. The slick aluminum in your laptop, the tough steel in a bridge, none of that just existed. It all had to be rescued. It started its life trapped inside a rock, locked away deep inside the earth. So, let's get into this. This is the big challenge, right? How in the world do we get from a boring old chunk of rock to something as amazing as a jet engine? The answer is this fascinating science called metallurgy.
When you boil it down, metallurgy is basically a three-step mission. Step 1, you got to get the metal out of its natural home, its ore. Step 2, you have to clean it up, get it pure. And then the fun part, step 3, you can start mixing it with other things to create brand new materials, which we call alloys. It's this whole journey from raw to refined to, well, really revolutionary.
Now you should know, not all metals are trapped in the same way. You've got a few, like gold and platinum, that are kind of loners. They're so unreactive, you can actually find them just lying around in their pure or native form. But most of the metals we rely on, the workhorses like iron and aluminum, they're super reactive. They're almost always found bonded with other elements trapped in these compounds.
Okay, so to really get this, there are two keywords you have to know. First is ore. That's the part of the rock with the good stuff, the mineral we actually want. You can think of it as the treasure. And then everything else, all the useless dirt, sand, and other rock mixed in, that's called gangue. That's the trash we need to throw away.
And here's what those mineral prisons actually look like chemically. Let's take aluminum. Its main ore is something called bauxite. If you look at the chemical formula, you see the aluminum, the Al, is right there. But it's basically in chemical handcuffs with oxygen. The entire point of metallurgy is to break those handcuffs.
And it's the exact same story for other huge metals. We pull iron from an ore called Haematite. And look, there it is again, bonded to oxygen. We get zinc from zinc blende, where it's locked up tight with sulfur. Every metal has its own unique chemical jail cell that we need to bust it out of.
So how do we stage this great escape? Well, metallurgists have come up with this amazing 5-step rescue mission to free these trapped metals. It's pretty slick. Here's the game plan. First, you take these huge rocks and crush them into a powder. Second, you concentrate the ore. That's just a fancy way of saying you get rid of all that useless gangue. Third, you convert the ore into a simple metal oxide. Fourth is the big one, reduction. That's where you finally rip the oxygen away and get the crude metal. And last, step 5, you refine it to make it super pure. Every one of these steps is its own little world of science. But let's just zoom in on step 2, concentration. This part is so important. I mean, you can't just melt a whole mountain, right? You have to separate the treasure from the trash. And the ways they do this are honestly brilliant.
One method is hydraulic washing. This is all about weight. You just blast the crushed ore with a powerful stream of water. The gangue is lighter, so it just washes away. But the ore particles are heavier and denser, so they get left behind. Super simple, super effective.
Or, what if your ore is magnetic but the junk isn't? Well, then you use magnetic separation. The powdered ore just moves along a conveyor belt with a giant magnetic roller at the end. The magnetic ore sticks to it for a split second longer, so it falls into a different pile than the non-magnetic gangue. It's such a clever idea.
And then there's my personal favorite, froth flotation. This is just pure chemical genius. You mix the powdered ore in a huge tank with water and pine oil. Then you blast air through it. The ore particles hate water but love oil, so they grab onto the air bubbles and float up to the top in a bubbly froth. You just skim the froth off and boom, you've got your ore. Meanwhile, the gangue, which likes the water, just sinks to the bottom. So cool.
All right, so once we've got our concentrated ore, we move on to step 3, turning it into a metal oxide. Now you might be thinking, why add another step? Well, it's way easier to steal one oxygen atom from a metal than it is to break apart some of the more complex minerals. We usually do this just by heating it up, either with air, which is called roasting, or without air, called calcination.
Okay, let's put it all together and look at a real titan of metallurgy, aluminum. Getting aluminum is notoriously difficult because its bond with oxygen is incredibly strong. It's pretty much the ultimate challenge.
And this is the battlefield.
It's called a Hall-Héroult electrolytic cell. So, after the bauxite ore is purified into alumina, that's just aluminum oxide, they dump it into this carbon-lined tank and melt it. Then they stick in these huge carbon blocks and pass a massive electric current through the whole thing.
So what's happening inside that fiery bath? Well, that powerful electric current basically acts like a chemical crowbar. It forces the positive aluminum ions over to the negative terminal, the cathode, where they gain electrons and become pure molten aluminum metal. Meanwhile, the oxygen gets yanked over to the positive carbon blocks, the anodes. The handcuffs are finally broken.
But here's the secret sauce that makes this whole thing actually work. Pure alumina doesn't melt until it's over 2,000 degrees Celsius. That's just insanely hot and expensive. The real genius here was discovering that if you add a mineral called cryolite, that melting point plummets to a much more reasonable 950 degrees. They also toss in a little fluorspar, which just helps the electricity flow a bit better. It's a total game changer.
So we did it. We rescued our pure metal. But the story isn't over. A lot of times, pure metals aren't exactly what we need for a specific job. And this is where we get to enter the awesome world of alloys, where we basically cook up our own custom super metals.
An alloy is really just a fancy word for a mixture of a metal with other elements. Take aluminum again. It's super light, but on its own, it's way too soft to build an airplane. But if you add just a little bit of copper, suddenly you get duralumin. Still light, but incredibly strong. Perfect for flying. Same with iron. Pure iron rusts like crazy. Add some chromium and nickel, and you get stainless steel. Tough, shiny, and perfect for something like a surgeon's scalpel.
And it's not always about strength. We design alloys for all sorts of special jobs. Solder, which is a mix of lead and tin, is designed to melt at a really low temperature, so you can join tiny electronic parts without frying them. And bronze, that ancient mix of copper and tin, it's amazing at resisting corrosion and it looks beautiful, which is why we still use it for things like statues and medals.
When you really stop and think about it, the journey is just incredible. That boring reddish rock, bauxite, goes through this whole epic process and becomes the wing of an airplane you can fly in. A chunk of iron ore becomes a tool that can save a life. Ores of copper and zinc are transformed into the brass of a trumpet, something that can create beautiful music.
From the very first person who discovered bronze, all the way to today's modern superalloys, metallurgy has always been about taking what the Earth gives us and reshaping it into the world we want to live in. It really makes you wonder, with everything we know now, what's going to be the next game-changing super material? What's next?